Okay, a domino is made up of two small squares, like this. Which of the following checkerboards, illustrated below, cannot be covered exactly and completely by a whole number of non-overlapping dominoes? So, sorry for not drawing all of these the right size. Their ability to print this on paper is better than my ability to draw it on my whiteboard here, but hopefully you get the idea. So what we're trying to do is imagine that we have some dominoes that will cover certain bits of these squares, and we're trying to figure out which one of the checkerboards below can't be covered completely by a whole number of non-overlapping dominoes. Well, let's see what they mean just by looking at the first one. So we can take our square, or our domino that has a dark square and a light square, and we could put one here, we can put one there, 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 and we can put one there. So we seem to be able to do that one. Let's check the next one, just to make sure we know what we're doing. We can put one there, 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 there. Oh, shoot, maybe I didn't do this one right. But okay, so you kind of get the idea, and see here we just unfortunately have one square left over. That doesn't necessarily mean this is the answer, by the way. It just means that maybe I didn't do it right. So I'm going to have to go back and check. But the question then becomes, if you glance at this one, it looks like we can sort of do it in the same way. And let's see if this one works. Okay, this one does work. And which is nice, and we're doing it. We don't need to go through and draw them all out. That's not the best way of thinking about one of these problems. The question is just going to be, what can we notice? And the really important thing to notice here is that the domino covers up two squares. Every time I laid my domino down, it covered up two squares everywhere. You can see that. It also covers it one dark square and one light square. That's another important thing to notice on problems like this. But the fact that it covers up two squares is going to be enough for us to solve this problem. Because in checkerboard A, we actually have 12 squares. In checkerboard B, we have 15 squares. In checkerboard C, we have 16 squares. On checkerboard D, we have 20 squares. And on checkerboard E, we have 18 squares. Now, I haven't checked if I can do D and E yet. Now, maybe you can just look at them quickly and see how to do it. That's fine. But because a domino always covers up two squares, it turns out what I thought maybe was just me not doing it right here is always going to happen. There's 15 squares you have to cover up. And that means that you're always going to have one left over, because a domino covers two squares, and when you count by twos, you're going to get to 14, not to 15. So the answer is going to be B. The other way I mentioned is you could look at it by, it always covers one dark square and one light square. Well, let's take a look at that. How many dark squares do we have here? 1, 2, 3, 4, 5, 6. How many light squares do we have? 6 dark, 6 light. How many darks do we have here? 2, 4, 6, 8. And we have 7 light. How many do we have here? 2, 4, 6, 8. 8 dark, 8 light. How many do we have here? 2, 4, 6, 8, 10. 10 dark, 10 light. Maybe you can figure out a way to count these dark squares faster than I am. And how many dark squares do we have here? Well, 3, 6, 9. 9 dark, 9 light. So because a domino always covers the same number of dark and light squares, it looks like for all of these, at least it's plausible that we can do it because they have the same number of dark and light squares. We don't know for sure if we can do all of those. We'd have to check. However, this one does not have the same number of dark and light squares. And that means there's no way we're going to be able to do this. And in fact, look, it has more dark than light. So notice when I had one left over at the end, it was a dark square. And that's simply because there are more dark squares than light squares. So that's a quick look at problem number 5. So on to the next one. Thanks for watching.